we would look very similar to these archetypal gray aliens with the big round heads, what we call neurocranial globularity, and especially with the enlarged parietal lobes. I mentioned that those are the area where we see the largest change in both size and shape. And then that's where this issue of religion comes in. Maybe a lot of these things that we do believe in a literal biblical sense did happen, but they didn't fit within the box of people at that time. So they created these ideas around them and tried to explain them the best way they could. And we're still trying to do that today. We're still trying to fit the reality of this phenomenon into the framework of religious belief systems. It doesn't neatly fit, so a lot of people say, "F that. I don't want to have anything to do with it." Other people are like, well, this must be demons. It must be demonic, like my dad. He's like, well, this is a thing, but he probably only believes it because he saw it. This is a thing, but it's this. It's this thing that I already understand, so I can put it in this smaller box within the bigger box. So he does bring the box in, but I think it's going to come to the point where the two boxes are one. Where this UFO phenomenon, kind of your original question, I guess, was how did they fit together for me? I think we're all going to be at that point where the UFO phenomenon, and historically and prehistorically, and then our belief systems are going to merge into one thing. And that was kind of what I was trying to do with this last book, is show how those are likely to come together.
Yeah. Now maybe it would be helpful just for everyone out there to follow along to break down, like you've obviously gone through some of it today, but to break down once and for all the extratempestrial model and what exactly it means and how the time travel could work, if you understand what I'm saying.
Yeah, absolutely. That's always a great place to start because, yeah, like I was listening to this book about the Akashic Record recently, and it was like the third chapter where she finally defined what she meant by the Akashic Record. I'm like, that really would have helped in chapter one because I had no idea what the hell you're talking about. So yeah, that's a great place to start. So the idea, as we sort of touched on previously, is just that we have had a long evolutionary history on this planet. We've evolved culturally, we've evolved physiologically, and if those same dominant trends continue into the future, we're likely to look like morphologically, and we're likely to have technology similar to what we see in these beings that are showing up now throughout recent history, throughout the prehistoric past, arguably. So what I mostly focused on and what my PhD research was in is craniofacial evolutionary anatomy.
Craniofacial evolutionary anatomy.
Yeah, so I mentioned these dominant trends. The most dominant ones are an increase in brain size, what we call encephalization, but also a change in the shape of the brain. So it got about 3 times larger compared to a chimpanzee or our earliest hominin ancestors. The ones people are most familiar with are actually about halfway through the Australopithecines, like Lucy, but you can go back another 3 million years before that. But throughout most of that time, we're really just evolving our postcranial anatomy, neck down, standing upright. How are we adapting to this new form of locomotion? Bipedalism, the trait that actually defines the hominin lineage. But after about the time of the Australopithecines, beginning with Homo habilis, about 2.5 million years ago, then we see the brain start to increase in size. It moves out over the eyes, and it increases mediolaterally.
Homo habilis, I'm not remembering that one. Where was the origin there?
So you've got the Australopithecines.
Yep.
So the gracile forms became us, the robust forms died out. So you have Australopithecus afarensis, africanus, and anamensis. And then they eventually, one of them or some of them, eventually evolved into Homo habilis. They were the first to make and use stone tools, which is why we call them that. It means handyman. Which was a really important innovation that allowed our brains to get bigger. It actually contributed to our brains getting bigger because there's this feedback loop. And our culture, our new abilities allowed our brains to get bigger. For instance, cutting meat with stone tools. We invented fire not long after that. So cooking our food allowed a reduction in our masticatory musculature. So the face could get smaller and get out of the way of the brain. And then the teeth got smaller, the chewing muscles got smaller, brain started to get bigger, and then the feedback loop comes because we think of new ways to solve problems and new ways to process our food, new ways to use fire. And so you can see the beginning of this sort of self-licking ice cream cone, this runaway brain train, as we call it, where our innovation drives new tools, our new tools allow the brain to get bigger, and it continued like that and accelerated, beginning with Homo erectus, about 1.5 million years ago. Our brains just really started to take off, move forward, like I mentioned, but also expand mediolaterally. It got bigger from
Mm.
left to right, especially in the parietal lobes. Um,
And what did we add? Like, what segments of the brain did we add there?
those are involved with motor functions. The frontal lobe, especially, is involved with higher level thinking, problem solving. It's sort of the thing that makes us more unique
Mm.
relative to other animals, relative to the great apes, too, because they have large brains for their body size, but they're not doing the same stuff we are. But a lot of it was a shape change, it was a size change, but importantly, it also changed the shape of our face, the size of it. So I guess I could break this down. A common example I use with dogs, you can think of a Doberman Pinscher versus a Pug or a Chihuahua, where the Doberman's got a long snout, really low sloping forehead, and then you shrink back the face, you add a forehead, and now you're looking at a Chihuahua or a
Mm.
Doberman or a Rottweiler, any sort of animal with that bowel plan. And you can see it across the animal kingdom. I use dogs because we did it to them in a relatively short period of
Yeah.
time. So it's also familiar to us. People know dogs better than they know past hominin ancestors. So it's, if I rattle off like all of these Latin names, it doesn't really make any difference. And the whole point of educating and teaching is to speak to people in a way they understand. Otherwise, you're just fulfilling your own egotistical dreams of saying things that people don't get, which kind of defeats the purpose. So if we think about the dogs, that's the main trend. Faces got small, heads got bigger, expanded out. And if you fast forward that, we would look very similar to these archetypal gray aliens with the big round heads, what we call neurocranial globularity, and especially with the enlarged parietal lobes. I mentioned that those are the area where we see the largest change in both size and shape. And then also larger eyes, kind of the wraparound eyes, and the more reduced and retracted face,
Why would the
pointy
eye?
chin.
Why would the eyes be bigger?
Yeah, that's a great question. One of my first academic papers after grad school was in a journal called Medical Hypotheses, where I laid out this theory about how these trends are likely to affect vision in a functional sense. So I was particularly looking at juvenile onset myopia, which affects a huge number of people throughout the world, but especially individuals in Eastern Asia, Southeast Asia, China, Korea, all over the place. Upwards of 80 to 90% of people have nearsightedness. And it's, not a huge issue today. And in this paper, I cited other people and also sort of added my own interpretation where you can see how that would happen, where you have the brain impinging itself on the eye, the face shrinking underneath it. And what you see in the myopic eye, if you imagine squishing a tennis ball from top to bottom, it squeezes out on the side.
Mm.
That's exactly what the myopic eye looks like. The reason we are nearsighted is because it changes the focal length from that extension of the
Ah.
eye out of the orbit, and it focuses light in front of the retina as opposed to on the retina, like it would in a perfectly spherical eye. That's exactly what we expect to see as the brain grows out over it, the face shrinks back, that it would sort of circumscribe the orbit and create that distortion to the eye. So to answer your question, in this paper, I cited some other researchers that have demonstrated that the eye and the brain have a pleiotropic gene relationship, which means that when we see two different organs, we see the brain and the eye as two separate things. They're actually controlled by the same set of genes. So they're essentially
Same set
one
of
thing.
genes?
Yeah. So pleiotropy just means you have different characteristics that are influenced by the same gene or set of genes. So therefore, they have the same growth and development. They have the same, in an evolutionary phylogenetic sense, they change over time together, evolutionarily and throughout growth and development. And the other thing is that the eye grows out of the brain. It grows out of the telencephalon during fetal ontogeny, which is a bunch of
Oh.
big words that just mean it goes boop and it comes out of that developing brain.
Oh, I didn't know that.
Yeah, so they are essentially the same organ. So if the brain gets bigger, we would expect that the eye would get bigger too, to answer your question. So we see them as two different things, but essentially they're one organ. So an increase in one we'd expect to see an increase in the other. Unfortunately, we can't study the eye because it's soft tissue. It decomposes, it goes away. We can study the orbit, but there's also a lot of other things in the orbit. There's rectus muscles, there's fat. But we can get a sense of those changes over time with regard to brain, eye. We can see the orbit changing. We can see how that shifts. And it was even 30,000 years ago with some ancestors and the Cromanian people. A lot of your listeners have probably heard of them. They had these sort of low square orbits, and then we started to get more increase superior inferiorly, top to bottom. Getting into the weeds a little too much here. Probably just lost a couple of your listeners.
No, not at all. It's very interesting.
Beyond that, there's just a number of other things too. Our bodies have changed. We've sort of gotten smaller. There's been a decrease in robusticity over the last 30,000 years.
We have?
Yeah. Yeah. And
has that a quick question? I'm sorry, because like we get lost in timelines where when you think 10 years ago, you can relate to it, right? And then you think 50 years ago, you can't relate to it. 100 years, it's almost like time gets exponential in how we appreciate it, if you understand what I mean. Mm-hmm. So if I look at something that objectively compared to the history of the Earth is not long ago, but for me is a long time ago, which would be 150 years ago. I don't have the numbers on me offhand, but I know like human beings were smaller in height and weight on average at that time. So are we saying that the weight has changed, the height and weight has changed down over time, but it's not necessarily linear? Sometimes it goes a little lower and then comes back up higher?
Yeah, that's a fantastic question, and you framed it perfectly too, because we see both. We do see an increase and decrease in height evolutionarily. Because, when we're talking about these Australopithecines, they're about 3.5 feet tall. Really diminutive, tiny creatures that got preyed on by all kinds of different animals. And then we started to get larger. We have this fossil called KNMWT 15,000. It was a Homo erectus. You don't need to know all that. That doesn't matter.
15,000.
That's just its catalog number. That's if you wanted to find it in the museum, Kenya National Museum, it was found in West Turkana. It's the 15.
It sounds like a Bond villain's weapon, but
it would be a cool band name too.
Yeah,
I mean nobody would ever come see because they couldn't remember it.
Nope.
But it's almost as bad as Extra-tempesto, for God's sakes. But no, that's the catalog number. But it was a Homo erectus from 1.5 million years ago, and this dude was big. Like he was only 11 years old when he died. It's thought he died from a cavity. And it created an infection.
Oh, wow.
And we can cure these things now pretty easily, but they didn't have dental medicine 1.5 million years ago. So homeboy died at 11 years old. And so we can project what he would have looked like if he got to be to a mature age. And he would have been about 6'1". Strong body build. The post-cranial morphology is almost identical to ours. There's differences. It's more similar to a Neanderthal of sorts.
I'm sorry to get into the weeds, but can you explain how it's more similar to a Neanderthal?
Just because of the robusticity. Because Neanderthals were like hefty. Their bones were big. They were built for a cold environment. Even though this individual, Turkana boy, as he's known, which is way easier than KNMWT 15,000, even though he was 11, he was still beefy, stocky, So but that 6'1" height, if that's an accurate projection, indicates we're already within and above the range of modern humans. I think the average today for males is about 5'9" or 5'10" or something, depending on what part of the world you're in. With that said, there is vacillation, what we call diachronic changes too. And that's one thing that one of my first research projects at Ohio University was to study people's occupations and changes over about 100-year period. And there's massive change. You look at the Depression, people got a lot shorter. Come out of the Depression, there's a boom time, people get taller.
What?
And you can see it within this. Yeah, there's a guy named, I think Richard Steckel is his name at Ohio State, who did way more research on this than we did. We cited him a lot, but we were also contributing to it. And yeah, it's crazy. Like it happens fast. When we go through a depression or a recession and people are cutting back on nutrient intake, I mean, that's affecting their children instantly.
Whoa.
And then those kids grow up and they're shorter.
Watching the video, guys, if you haven't already subscribed, please smash that subscribe button and check out this clip's full podcast episode by clicking here